In this section, what we try to learn how to find volumes of 3D objects. So volumes of 3D objects. So we can talk about two methods. So we can talk about the what we call the disk method, and then we talk about the washer method. So there are two methods, disk method and the washer method. So in the exam there will be two questions, one from the disk method, one from the washer method. And in the next section we can talk about one more technique, that what we call the cylinders method or the shell method. That's the next section. Okay, and that's that's the last topic that we gonna cover in the next exam. Okay, so before we talk about more things, let's learn few terms. So we have what we call the cylinder. So when we say cylinder, so there are a few different cylinders. So one cylinder is like, let's say you have one parallel section, and then there's a similar parallel base. So that's the parallel base, and then we have these two joined. So this is what we call a cylinder. So it doesn't matter what shape you have, but those two shapes has to be the same. So that's the only idea. So then what is the volume of this? So if you want to find the volume of this cylinder, so what's going to happen? So we're going to call this is the height, and then this base has the area. So I'm going to call this A is the base area. So if you know the base area and the height, so the volume is simply base times height, so AH. So that's the volume. Volume is AH. That's the first type. And then we have, so this is just a cylinder. And then we have like a circular base. So the base is like a circle, like that, like this. So this is a circular base. So like this. Okay. So we have base. They are the same, but it's a circle. Okay, this is a circle. So the same thing, the height and the base area. So the volume is H, base times height. A is the area. That's the area. That's the height. This is the height. So so then we have this type, and then we can have another cylinder. So like we have one like that, the another one is like this. So they are parallel but not like one above the other. So like this. Okay. So you can see just like that. And then again the base area is A, and the height, but we don't take the height like that, so we can take the height like this. So this is the height. So you can see it's slightly different from, so that's the height. So the distance between two parallel planes. Okay. So again the volume is H, but this H is not L. L is like this one. So it's not L, it is H. Okay. So there are special names for this one. So this is like generally a cylinder, and then this is what we call a right cylinder. Why right? there's a 90 degree here, so the base and the height, they're like perpendicular, so that's like a right cylinder. And this is what we call a right circular cylinder, because that's a 90 degree, and at the same time the base is circular. So this is right circular cylinder. Okay, so there are three names. So the cylinder, general cylinder. So only thing is those two bases has to be parallel. So these two are parallel. This and this, those two are parallel to each other. The same thing happening in everyone, because that's just a general cylinder. And then the height is the distance between those two parallel bases. So we have cylinder, right, and then the right cylinder and the right circular cylinder. Okay, so 1, 2 and 3. So that's the kind of order. Okay, so that's one idea. So because we can use this a lot. Okay, so how to find the volume of a general cylinder? So what you need the base area times the height. Height is the distance between the two parallel. The height is the so h, which is the height. This is the distance between parallel planes. The distance between parallel planes. So that is the height. Okay, after you know the height, then the volume V, that's the volume, it is A times the height. Okay, so that's the first idea. And then let's see what we're gonna do. And then also there are a few other things that need to pay attention. Even before, like, we do anything, I'm going to go with these things because that's important. So I'm going to say important. The first one, so what we're going to do, so before integrating, rewrite the integral using only one variable. So that's very important. Okay, because that's where most of the students make mistakes. So before integrating, rewrite the integral using only one variable. That's very important. And then how we do it, remember, like, how we find the area. So if you want to find the area, what we're going to do, we're going to cut it, we're going to strip into rectangles, right? Because we have an area, so we're going to cut into small rectangles. But what's going to happen, these are solids. Since these are solids, when you cut it, you don't get a rectangle, you get cylinders. When you cut it, you get a cylinder. So you get a general cylinder. You're going to have two parallel sides, and then and so it's like the case 1 in this case, so cylinder, just a general cylinder. That's what you get. So you need to find the distance between the two parallel planes and the area. So that's all you need. So what I will tell you, so when you cut it, you always cut in this section, you always cut perpendicular to the axis. Okay, so cross sections are perpendicular to the axis of rotation. Rotation comes later. but let's say so what we can say, the axis is always so there's axis for these kind of problems. So you can see that these cross sections are perpendicular to the axis of rotation. Okay, so those two, please remember those two, because it's gonna save a lot of time, because sometimes what happens, students try to kind of understand that at the last minute, at the end of the section. So but pay attention to those two things. So you need to write the integrals in only in one variable. That's very important. And also the cross section has to be perpendicular to the axis. Okay, so let's try to develop the theory, and you can see that it's not that difficult. So so let's work on that. So so I'm going to say the first one, volume by disk method. Volume by disk method. Okay, so so let's say you have an object. So this is my object. So this is like a 3D object. Okay, so this is like a 3D object. So what we're gonna do, so once you get the object, you can see that it's not, doesn't make like it does not have a real like nice symmetric shape. So any object. So what we can do, the first thing, we're gonna place them on a set of axes. So I'm gonna because 3D, so these are my axes. So the y-axis, and then we have the x-axis, so and then we also have the z-axis. So there are 3 axes there, but we are worried about only x and y in this case. So that's the first thing. So you have axis. So you see the object, and then you place the axis. That comes second. Now what we're gonna do, we're gonna cut the object perpendicular to the x-axis. Okay, so here this is the axis. I'm gonna pick the x-axis, and then later we can do y-axis, but for the moment we're gonna cut perpendicular to the x-axis. So once you cut perpendicular x-axis, depending on the shape, so this is what's gonna happen. So you cut it. So you cut into thin slices. Just to make things easy, let's say we're gonna cut into equal pieces. It's not really necessary. So so the starting point is A. That's where the integration limits start, and the ending point is B. That's the last one in the object. So B. So they have A and B. So what we do, we're gonna slice it perpendicular. So so slice the object perpendicular to the x-axis. In this case, x-axis. Okay, not always x-axis, either x or y. But in this case, we're gonna cut into x-axis. So once you do that, how it looks like? So this is like thin slice. So so this is how it looks like. So and this the so this is just one slice. So this is the thickness of the slice. Okay, so yeah, this since this is the first example, I just do that just to get the idea. So this is how it looks like. So when you cut it, you're gonna get a small slab or a so, and then how it looks like. So and then so you can see, so there's a starting point and there's an ending point. That's around the beginning and end. So the beginning part, so you can say this is the xi minus 1, and that's I'm gonna call xi. Okay, so this is the so you're gonna cut into pieces. So you're gonna say, so starting with, this is what we normally call x0. So we have x1 piece, x2 piece, like that. Okay, so this is xi piece, and then I'm gonna continue. So it's gonna continue, and this is xn piece, nth piece. So we'll cut into n parts. Okay, that's how it looks like. So this is the part, the ith part. We're going to start with naught, so you're going to go to 1, 2, 3 like that's the ith part. So what we're going to do now, we're going to pick something in between. So let's pick some value in this interval. I'm going to call x star. Okay, so we can say, since the ith one, so you can say xi star. So that's the piece. That's the piece. That's the number between xi minus 1 and xi. So just pick some value. Now what we're going to do, we're going to find this area. So what is this area? So I'm going to call A. So so the A, actually this is AXI, the area of the ith one. That's the area, the area that exactly passes through this xi star point. Okay, so this is the area of the cylinder or the base. Okay, area of the base of the cylinder. You can see that it may be slightly different, but we can see that they are very, very close to each other, because you can make this gap very, very small. Okay, good. Now, and also if you can draw this slice again here, so this is how it looks like. So that's that slice that you had over here, like that. So that's the slice. Okay, so that's the shaded one over there. So I'm going to draw it again here. This is how it looks like. Okay, so that's that area AXI. That's the base area. So this is the height. You see that? That's the height h. Okay, that's the height. But what happened, since this x is moving in the since this the thickness or the h moving in the x direction, what is height? This height is simply delta x. You can see this height simply become delta x. This is the height. So that means that delta x gonna go here. So that's the height, delta x. Okay, so that means you can find the volume of this small piece. We can say ith piece. It is simply we can say A xi star, that's the area, times the height, delta x. So that is the volume of one such piece. So if you want to find the full volume, what do you do? Just add all of those pieces. How many pieces we have? There are n pieces. Okay, n pieces. So so the complete volume simply going to be V is approximately equal to the sum of all those pieces. So it's I going from 1 to, there are n many pieces, just add all of them, x I star, and if you say those are, if you divide them equally, then you can say delta x, but not necessarily. You can divide into different pieces every time. Okay, so that's the kind of idea. And then what's going to happen, then you can say if you send n to infinity, then you get the volume. Okay, so so the volume is simply given by the limit n goes to infinity of this sum I going from 1 to n a x I. When sending n to infinity means you can cut into more and more pieces, so that means this is a really good approximation of delta x. Now what's gonna happen, this is simply, we know that this is simply the integral, so integral going from what value, starting with the a value to the b value, a x delta x. Okay, so delta x become dx, delta x become dx, and this part we normally write just as ax without the star. Okay, so that's the formula. So so finally we can write the volume formula is, so the volume, so this is the formula thing. Remember, it is going from a to b, ax dx. Okay, so this is for the disk methods. You find the volume, and then volume. So how to do it? You just find the base area and then integrate. That's it. Okay, so that's the base area of the xth position. Okay, so the base area of the cross section, base area of the cross section at xth position. Okay, so that's the only formula that we use. So we in the next section, not in the next section, when you go to the washer method, we slightly modify this formula, but for the moment this is simply the formula. Okay, so it is just one formula we slightly modify and it's gonna do the job. Okay, so so let's kind of focus more on the disk method now. Okay, so what we're gonna do now, what will happen in the disk method situation. So we have the disk method. There's still we are in this method, but what will happen? So we're gonna do what we call the solids of revolution. Okay, solids of revolution. So we have something called solids of revolution. So what is solids of revolution? So what we're trying to do, let's say you have a curve, something like that. That's a curve which is going from A to B. Now what we're going to do, we're going to rotate this about an axis. Okay, any axis pretty much. Okay, so so you pick axis and rotate. So just to make things easy, I'm going to rotate about the x-axis first. Okay, so that's the axis, so you're going to rotate it about, so we're going to draw the rotation like that. So we're going to rotate about the x-axis. Once you rotate about the x-axis, what will happen? This area going to create a image on the other side, so that means it's going to get a reflected, so you're going to get something like that. That's what happened. So right, so you're going to create something like that, and then it's going to create a solid now. So I'm going to draw the solid like this. So this is a solid, so it's going to create a solid. So it's going to create a solid like that. So it's a solid now. Now what's going to happen? So you're going to pick the xth position, and once you cut it, what are you going to do? You're going to create a, what it will create? It can create a disk. See that? Yeah, I'm going to slightly modify it here. So it's going to create a disk. That's the disk we are talking about. It's going to create a disk. It's like the disk method. So that means to find the area, what we need is we just need the radius. We only need the radius, so things are easy in this situation. So we just need the radius at the x position. So that means if you say this curve is y equal fx, so what's gonna happen, what you need is this one. So this is simply the y coordinate, you see that? So the radius is the y coordinate. So that's the disk. So I'm gonna color it. Okay, so that's the disk. So if you draw it again here, so if you put it down there, it's going to be like that. So that's how it looks like. And that's the disk you are talking about, and that's the x-axis going like that. Now that's the x-axis, and that's the rotation you had, and that's the y. Is the y. Okay, so so what you need according to the formula, we only need the base area. Okay, so the area, actually the base area is simply ax. What's going to happen? This is a circle, so right? So this is a circle. So that means this is simply pi r squared. But this is pi, in this case y squared. Okay, so that means we have a slightly different formula now. So it is v pi r squared, and then a to b, you're going to integrate along the x direction, so it's become a dx problem. Okay, so the r is the radius. R is the radius. So that's the new formula. Okay, so so this is formula number 1. Now we have formula number 2. Okay, that's slightly modified. So r is the radius here. Okay, so this r in this case simply becomes the y coordinate. R becomes the y coordinate. Okay, so that's the theory for the disk method. So when you have the disk method, you only need to find the radius. So it may be the y coordinate, or if you do the other way, it may be the x coordinate, or maybe something else as well. Okay, so let's do some problems. Okay, so the disk method formula is number 2. Number 1 is just the general formula, but here for the disk method we can use the number 2. So let's do the first example. This is one of the exciting example. So what is that? Show that the volume. So that the volume of a sphere. So that the volume of a sphere of radius r is, so that the volume of a sphere of radius r is how much? What is the volume of a sphere of radius r? It is v equal 4/3 pi r cube. So we can derive this formula now. Okay? We can derive this formula. The volume of a sphere is 4/3 pi r cube. So let's see how it's gonna work. So we have some drawing. So what we're gonna do? So this is a solid. So we're gonna place the solid on the coordinate system. So you have to be careful in these situations. Actually, I'm gonna draw a little large one. so it's gonna be a little bit clear. So what I'm gonna tell you, you need to be very careful how to place the axis, but it will come from practice. So okay, so that's the sphere. So what we're gonna do, we're gonna place the coordinate origin of the coordinate system in the center. Okay, so that's one important thing. I'm gonna put that in the center. So, and this is your x-axis. Okay, that's your x-axis. That's the x-axis, and that's the y-axis. Now, so what we're gonna do, you can think of this as a solid of revolution. Why is a solid of revolution? What you can do is you can get a disk, and then you can rotate it about the x-axis. So I'm gonna disk and rotate about the I'm gonna get a circle. Why we say disk? Because there is something in the middle. That's why we call it a disk. And then we can rotate about the x-axis. Once you rotate about the x-axis, what is gonna happen? So you have a disk, and then you're gonna rotate it. It's gonna generate a solid. Is that clear? So you get a disk. So you get a disk. You get like a circle, and then rotate about this axis. Once you rotate about this axis, it's gonna sweep through a complete sphere, right? Because there's something in there. So it's gonna once you rotate it, it's gonna completely create a complete sphere. So that's the kind of idea. So that means once you do it, now again, as before, we're gonna cut parallel to, perpendicular to the axis of rotation. So when you cut in the perpendicular axis of rotation, so perpendicular to x, so what's gonna happen? So so this is gonna be the disk. Okay, so once you cut it, you're gonna get a disk like that. That's what it's gonna look like. So that's your disk. Okay, that's your disk. So that's the x position. This x is from the origin. So you go x distance, and this is the corresponding y. So you always have to combine or relate x and y. So that's happened. So that's what you need to learn. So now, so what's gonna happen? If you look at the xy cross section, xy cross section, what's the xy cross section looks like? What's the xy cross section looks like? It looks like this. This is xy cross section. That's your x-axis. That's where that x position over here, and this is the y coordinate. That's the y. All right, and this is the radius r going from here to there. That's r, and that r is exactly here. That's the r. Good. Okay, so now what we want to do, we want to find the base area, the area of this cross section. So like area of this one. Okay, we need to find this area. What is the radius of this area? The radius is simply the y coordinate. So right, so that's the radius. Radius equal the y coordinate. Okay, so the area is ax, which is, we say ax because x is the changing one. Okay, and it's going to go from 0 to r. Okay, so now so this is pi, the radius squared, pi. What's the radius here? What's the radius of this this disk? Is y. Okay, radius is y, so it's a y squared. Very good. Okay, so that means then you can write the integral. So the volume volume is pi y squared dx or dy. You can see the disk moving in the x direction. Okay, so that means it should be a dx problem, moving in the x direction. You can cut along the x direction. Okay, so you can say cut perpendicular to x-axis. That's where it's coming from. Cut perpendicular to the x-axis. Okay, and then you're going to integrate this. Okay, now it's interesting. Integrate from where to where? You need to consider the whole disk. So if you consider the whole disk, it's even extend to this direction as well. So it's going to go all the way there. So it's going to go from negative r to positive r. Alright, going from negative r to positive r. So it's going from negative r to positive r. So that's the whole formula. Now what we want to do is we want to solve for this one. But you can see that, remember first condition. What's the first condition? Before you integrate, so everything looks good now so far, but before you integrate, you need to write everything in terms of one variable. So there's no way you can integrate this because you have x and y both. But you know that your variable is x, so that means you need to express everything in terms of x. Okay, so write everything in terms of x. So let's do that. So how to do that? For that, we can use the Pythagorean identity. From the Pythagorean identity, you can write x squared plus y squared equal r squared from the Pythagorean identity. From that, you can say y squared equal r squared minus x squared. We can use that to replace y squared in terms of x. Okay, so that's the idea. So that's what we can do in the next slide. Okay, good. So so let's finish the problem now. So the volume which is going from negative r to r pi y squared dx, and you know that this is not allowed because you have to bring everything into one variable. For that, we can use the condition y squared equal r squared minus x squared that we just derived. So that means it's going to be negative r to r pi, what is y squared? R squared minus x squared dx. Is this good now? Yes, you can see that the variables are the same. R is a constant, so same. So that means good now. So we're gonna integrate now. Okay, so remember, so you have to bring everything into one variable before you start integrating. Okay, now this is a very simple integral. You can integrate this term by term. So you're gonna get pi, what's integral? R is a constant, so it's r squared x minus r 3 x3 over 3. Okay, and then you do r and minus r. So let's plug in that. So so if you plug in, so there are two ways to do this actually. You can also get the half of it and then double it, but let's do that. So if you plug in r, so what do you get? So so if you plug in, so it's a pi, if you plug in r, you're gonna get r3 minus r3 over 3, and then minus pi, you're gonna plug in negative r. If you plug in negative r, it is r squared negative r, and then negative r cube over 3 and then if you simplify, the negative sign comes out, so it becomes positive. That means you're going to double it, so that means you're going to end up getting so what do you get here? Is going to be 2/3 r cube, and here also you're going to get 2/3 r cube if you simplify everything. So with the pi, is going to be 4/3 pi r cube. Okay, so that's the formula you were looking for, and you can see that it's not that difficult. And also I'm going to give you a note. So the note is you can also get the volume twice. We don't integrate the whole thing, we only integrate from 0 to r. So because by the symmetry you can see that if you just get half of it, you double it, you get the full volume. So that also you can do, you put twice only half of it. So so pi r squared dx, so you can do that, and this also end up getting 4/3 pi r cube. And also this might be easy because you have a 0, so that means you don't want to plug in anything. Okay, might be easy. So yeah, so think about that. When you have a symmetry, you can also use that idea. You integrate half of it and you double it. Okay, so that's the kind of idea. So you can see that, so that's the formula that you were using for a long time, and now we prove the formula. Okay, let's do more examples. Let's do another one. So the next example is example number 2. So so let's say find the volume. Find the volume. Okay, find the volume. Find the volume of the solid. Find the volume of the solid obtained by rotating about x-axis, about the x-axis, the region, okay, the region under the curve, y equal square root x from 0 to 1. Okay, find the volume of the solid. Find the volume of the solid. So what we find? The volume of the solid obtained by rotating about the x-axis. Is very important. About x-axis, the region under the curve y equals square root x from 0 to 1. It's always a good idea to kind of draw the situation, so how it looks like. So let's try to find the, so the whole goal is to find the radius, right? So let's look at the region, how it looks like. So it's the y equals square root x, that's this curve. It's going from, say, 0 to 1. So that's the curve, y equal square root x. Now what we can do, we can rotate it. So once you rotate it, so that's the radius. The radius can generate a disk. Alright, so it's gonna bring to the other side like that. So that means once you do it, it looks like this. So that's the region, that's the solid we are talking about. So what you need is the radius, which is the radius is equal to the y coordinate as before. Okay, so that means we have everything we need. So the radius equal r, which is equal to the y coordinate. So the x is simply pi r squared, but r is equal to y, so it's a pi y squared. But what is y? Y is given as a function now, so it is simply pi square root x squared. That means pi x. Okay, so that's always the goal. Find this base area or the typical area first. So it is in this case pi r squared, which is equal to pi y squared, and then which is equals to pi square root, because we know that y equal square root x. Okay, y equal square root x, so you're going to plug in. So y equal square root x, so you plug in that. Okay, that's the y, but which is equal to square root x. So you plug in and then simplify. Once you simplify, it is pi x. Okay, so everything looks great. Now we just need to integrate. Okay, so let's finish the job now. So the volume v equal, so it is, what are the limits? It's going from 0 to 1, so it is ax dx. We always write it like that. Okay, and then we're going to plug in. So we say that we simplified is 0 to 1 pi r square dx, and then 0 to 1. I'm just writing everything, but since we found it, we don't need all of them right now. So pi y square dx, and then it is 0 to 1 pi y equal square root x square dx. So that means it is 0 to 1 pi x dx. Now you can see that the same. Okay, they are the same, so we can integrate. This is where we can integrate. So we integrate. Once you integrate, you're going to get pi x squared over 2, 1 and 0. So you plug in 1, you're going to get pi half. Right, pi half unit squared goes area. I'm sorry, we need cube. It's a volume. Good. So you can see that it's not a difficult problem. It's like an easy problem. Right. So let's do one more example. But this time, what I'm going to do, I'm going to rotate about the y-axis. Okay. So let's do a different example. Rotate about y-axis. About y-axis. Okay. Let's start with the problem. So example number 3. Find the volume of the solid obtained by rotating. Find the volume of the solid. Find the volume of the solid obtained by rotating. Obtained by rotating the region obtained by, find the volume of the solid, volume of the solid obtained by rotating the region bounded by y equal x cube, y equal 8 and x equals 0, about, you always need to pay attention to what region, what axis. Okay, about the y-axis. Okay, now it is a y-axis. Okay, so first let's try to draw the region, because that's very important. Okay, so what's the region looks like now? Okay, so let's read the question again. So what it says, find the volume of the solid obtained by rotating the region bounded by y equal x cube, y equal 8 and x equals 0 about the x-axis. So just pay attention to this in quadrant 1. So if you graph it, this is how it looks like. So this is 0. So what's the region looks like? So it's the x cube graph. X cube graph goes like what? It's gonna go like this and then go down, but we don't need that part. Okay, we only need the part in the first quadrant. So that's how it looks like. And then it's gonna go, so that's the y equal x cube. and y equal 8. That's the y equal 8 line. That's y equal 8 line. And then x equals 0 axis. So this is the x equals 0 axis. That's x equals 0 axis, the y axis. So that's the region we are talking about. Okay, so that's the region. So what do you need now? Actually, in this time you can rotate about the y axis. Remember, when you rotate, you always need to cut perpendicular to the axis of rotation. So that's the axis of rotation. So you're gonna cut perpendicular to this axis. Okay, so if you cut perpendicular to this axis, your typical disc look like this. That's how your typical disc look like. So so you are looking for this radius. Alright, so you can see this radius is now the x coordinate. See, so that's the radius, but it is the x coordinate now. It's not the y coordinate anymore. Radius equal the x coordinate. And then your solid looks like this. So that's your top, and it's gonna go like that. So that's how it looks like, and that's your typical disc. So you need to find the area of this disc. Okay, you need to find. So that's the axis of rotation. This axis of rotation. Okay, so so this is 8. Good. Now so the radius, so you can see so the disc now going in the y direction. Okay, so you're gonna cut perpendicular to the y axis, so the disc moving up and down. Okay, so that means that it's a dy problem now. It's a dy problem. Okay, so it's a dy problem. It's not a dx problem anymore, because it's going in the top and bottom. So the way y is changing. Okay, good. So the radius is x coordinate now, because that's the radius of that. So that means you need to solve for x. So we know that y equal x cube. So that means this is x equal y 1/3. Okay, because it's a dy problem, that means you need to express everything in terms of y. So that means this x now you're going to replace by y, so it's a y 1/3. Okay, so it's coming from here. You always have to do that. It has to be in terms of only in one variable. So now so it is it's not ax anymore, it's a y problem now. So it is pi r squared, so it is pi y 1/3 squared, so that means pi y 2/3. Okay, so that means your volume, which is a y base area times what's the thickness? The thickness is a dy now. That's the thickness. See, so it is a dy or delta y. Dy or delta y. It's the limit. So it's a dy. That's the thickness. So limit going from 0 all the way up to 8, because this has been limit of y. Right? Limits of y. Okay, so let's finish the rest of the integral. So we know that this is 0 to 8 pi y 2/3 dy. Very easy to integrate. So so pi, you add 1, so it becomes y 5/3 divided by 5/3 8 to 0. Once you plug in 8, so you get 3 pi over 5th 8 5/3. If you take the third, that's 2, and then raise to the 5th power, that's means 32. So you're gonna get 96 pi over 5th. Okay, so that's the whole problem. So the best thing would be go over this several times until it is very, very clear. So you can see that these problems are not that difficult. And in the next video I'm gonna discuss the washer method. Okay, so far we discussed the cylinders method. In the next video we can discuss the washer method. Okay, thank you.